well, section 5, chapter 1, and then that'll be the end of chapter 1, and we'll get to some exercises. Exercises, I think, will be more, you know, it's not just going to be reading. We're going to try to discuss them, and even, you know, it should be interesting. It's been a while, and you know, the exercises, I don't expect, I've tried to find a key, or just even other people's selected key of solutions to make sure, but we're just going to be on our own. So I don't, you know, even if it was just stupid mistakes, I imagine I'll make mistakes, and I will make them in public. People could give me feedback. We'll see how careful I have to be presenting that stuff. Maybe, you know, I'll do slide presentations for the very first set. We'll just go through them, and I'll try to see some fair use, you know, minimal. I've scanned the page of exercises. We'll see how that works. We'll just play that part by ear. But anyway, the last section, chapter 1, Benson Mates' Elementary Logic, section 5, Logical Form. One of the most obvious and yet important facts about necessary truths was noticed by Aristotle at the very beginning of the history of logic. It is this. See, Aristotle was discredited with being, okay, anyway. It is this. In a large class of cases, when a sentence is necessarily true, all sentences of what may be called the same logical form are likewise necessarily true. The point will become more clear in examples. Consider the necessary truth. Socrates died in 399 BC, or Socrates did not die in 399 BC. This sentence remains true and even necessary when its sentential component, Socrates died in 399 BC, is replaced at both of its occurrences by any other sentence whatsoever. Thus, the sentence Aristotle died, or did not at that time. Aristotle taught Alexander, or Aristotle did not teach Alexander. Plato taught Alexander, or Plato did not teach Alexander, so on. They're all necessary truths, and so is every other sentence of the form S or not S. Again, the sentence is, if grass is green and snow is white, then snow is white. If roses are red and snow is white, then snow is white. If roses are red and grass is green, then grass is green. These are all necessary as well, as are all other sentences of the form, if S and T, then T. Still other examples are afforded by the conditional corresponding to the first argument mentioned in section 1 above, and by all other conditionals of the form, if all B is C and all A is B, then all A is C. When, as in each of these cases, a necessary truth has the property that every other sentence of the same form is also necessary, we shall say that it is necessary by virtue of its logical form, or logically true. Lest anyone suppose that every necessary truth is necessary by virtue of its form, we hasten to add the time-worn example, no bachelor is married, which is necessary, although many other sentences of the same form, no senator is married, is not. Even though not every necessary truth is necessary by virtue of its logical form, however, a plausible case has been made for the somewhat weaker claim that every necessary truth is either itself a sentence necessary by virtue of its form, or else is obtainable from such a sentence by substituting synonyms for synonyms. The sentence, no bachelor is married, for example, is obtainable from the sentence, no unmarried man is married, i.e., no man who is not married is married. By putting bachelor for its synonym, unmarried man, and the last of these sentences is necessary by virtue of its form, since every sentence of the form, no A, that is not B, is a necessary truth. We may note in passing that in view of the interdependence of soundness and necessity, one can make a corresponding division of sound arguments into those that are sound by virtue of their logical form and those that are obtainable from such arguments by putting synonyms for synonyms. Thus, every argument of the form all B is C, all A is B, therefore all A is C, is sound and will belong to the first type just distinguished. The argument Smith is a bachelor, therefore Smith is not married, is sound and belongs to the second type, for it's obtainable from an argument of the form X is a B that is not C, therefore X is not C, by putting bachelor for man who is not married. Thus, The concept of logical form is obviously of central importance for our subject. Equally obviously, it is a concept requiring a great deal of clarification. We need practical criteria for deciding what the logical form of a given sentence is, and which are the forms that have only necessary truths as instances. Unfortunately, the irregularity of natural languages makes the achievement of such criteria difficult, if not altogether impossible. Only in the case of artificial languages is there any real prospect of success. Are you guys okay? Let us look for a moment at some of the expressions we have used in describing the forms of sentences. S or not S, if S and T then T, if all B is C and all A is B then A is C, no A that is not B is A, there is B, X is a B that is not a C. In the first two of these cases, S or not S and if S and T then T, one obtains particular sentences by replacing letters S and T by sentences. These letters and all others to be used for the same purpose may be called sentential letters. In the next two cases, we must substitute general terms, men, mortals, professors, Swedes, not sentences, in order to obtain particular sentences. The letters A, B, C, and capital, and all others for which general terms are to be substituted are class letters. In the last case, we have, so this is really crucial, right? They have sentences, which are declarative sentences, completely formed, and that is separate from the objects in predicate logic. You're going to be able to variabilize over the objects in first order logic, but if you variabilized over the sentences, which is funny because you put a variable, you put the letter T, but you can't quantify over them. So I consider that the variabilization thing. It's my own personal way of thinking about it, but basically you can't say in first order logic, you know, there exists a sentence S such that blah, 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 blah. Right? So this turns out to be a really important distinction in all logic, because even in logic where you can quantify over the predicates, you still have this nice distinction of what that means, and that it's different than quantifying over objects. Okay. In the last case, we've used the letter lowercase x, for which names of individuals like Socrates, Aristotle, Alexander, or a description of individuals like the teacher of Alexander, the student of Plato, are to be substituted. Letters for which expressions denoting individuals are to be substituted are called individual letters. And while we are at it, let us introduce the term matrix to refer to the formal expressions themselves. A matrix is an expression built up out of so-called logical words like and, or, if, then, not, all, is, together with sentential, class, or individual letters, and such that the result of replacing the letters by the appropriate kinds of expressions is a sentence. Okay, thus we may say that a sentence is a truth of logic if and only if it is a substitution instance of a matrix, all instances of which are necessary truths. Observe that the notion of a matrix, which here plays a crucial role, will vary with the choice of a list of logical words. Unfortunately, the question as to which words should be considered logical and which not involves a certain amount of arbitrariness. Sometimes one defines the truth of logic as substitution instances of matrices, all instances of which are true. The advantage of this approach is that it explains logical truths in terms of truth, which is a relatively clear notion. Its principal disadvantage is its presupposition that the language contains a name or a description for every object and a corresponding predicate for every property. Otherwise, the nameless objects or properties might be just the objects or properties for which a given matrix would be false. But for various reasons, this supposition is not plausible. The above idea has an important variant, however, that is the supposition that you have names and predicates for everything. For various reasons, we don't have them, and there's many things for which it looks like they could not possibly be built. Okay, the above idea has an important variant, however, that escapes the difficulty mentioned. We may define a sentence as a truth of logic if it is a substitution instance of a matrix that comes out true no matter how one interprets the various individual class and sentential letters occurring therein, where interpreting a letter consists in assigning an appropriate object, an individual, a class, or a truth value, to it as its denotation. Thus the matrix X is an A, or X is not an A, comes out true no matter what individual is assigned to X and what class of individuals is assigned to A, and hence every instance of it is the truth of logic. This approach, which seeks to explicate logical truths in terms of a notion of coming out true with respect to interpretation, is in effect the one to be used in our later developments. Oh, I was wrong. There's one more section, 6. Yeah, I was small. Okay. Artificial languages. In recent years, nearly all serious study of logic has employed the device of an artificial or formalized language. The idea of constructing such languages goes back at least as far as Leibniz, although the first really successful attempt was made by the German logician Gottlob Frege. Is it Frege or Frege or Frege? How do you say Frege? Feel free to correct me. Oh my god, this is even worse. In his 1879 work, Begriffsschrift, it has always been clear that some degree of formalization is inevitable if the subject is to be pursued at all. Even Aristotle had to introduce a certain stylization of language in order to carry out his investigation. For the very simplest of what have been called laws of formal logic always require some adjustment in their application to a natural written language. I see so many people, they're atheists and atheists, and they're debating logic, and they don't make this distinction. You know, that there has to be some formal, technical. For instance, although the sentence "all men are mortal," or "not all men are mortal," is an exact substitution instance of the matrix S or not S, i.e. it can be obtained from it by putting "all men are mortal" for the latter S, though even here we must make a slight adjustment by capitalizing the initial A in one of its occurrences and not in the other. The sentence "Socrates is mortal" or "Socrates is not mortal" is not strictly such an instance, right? All men are mortal or not all men are mortal. Socrates is mortal or Socrates is not mortal. Is it not strictly? Okay. In connection with this particular matrix, the difficulty stems from the fact that although the denial of an English sentence is usually formed by adding the word "not," there is no simple rule for determining where the addition is to be made. We form the denial of Socrates as mortal by inserting the word "not" right after the verb. But if we try to deny the sentence "all men are mortal" in the same way, the result is "all men are not mortal." Whereas what is wanted is the much weaker sentence "not all men are mortal." To deny the sentence, Smith cracked the safe and Jones drove the getaway car, one is forced to prefix some such phrase as "it is not the case that," or possibly even to substitute either "Smith did not crack the safe" or "Jones did not drive the getaway car." This example also shows that even so simple a sentence as Smith cracked the safe cannot be denied merely by adding "not." Two other changes must also be made. You ever think about that? Thus, although when we say that all sentences of the form S or not S are logically true, we mean to include such cases as "all men are mortal" or "not all men are mortal," "Socrates is mortal" or "Socrates is not mortal," and so on. We see that, strictly speaking, relatively few of these are of the form mentioned. Similarly, the sentence "if all men are mortal and all Greeks are men, then all Greeks are mortal" is not strictly of the form "if all B is C and all A is B, then all A is C," since "is" has to be adjusted everywhere to R. Adjustments of this sort are the rule rather than the exception. In general, it is clear that for the natural language there are few, if any, matrices that literally have only necessary truths as substitution instances. If therefore we try to develop a formal logic of the natural language, we find ourselves unable to proceed in an exact way, even in the very simplest cases. An obvious remedy for some of these difficulties, and a remedy utilized by nearly all modern logicians, is to set up an artificial language that is grammatically simpler and more regular than the natural language. For such a language, one can hope to characterize the notion of logical truth in a satisfactorily precise way. After another chapter of preliminaries, we shall follow this approach. All right, and then we have the exercises.